Okay, so this is grade 11 pre-calc, lesson 40, graphing absolute value equations. So what you got to remember is you got to remember what absolute value is. Absolute value is written with the two vertical bars around this, and all it represents is the distance from zero. So for instance, if I say, what is the absolute value of 3? How far is 3 from 0? It is 3. Absolute value of negative 7. How far is negative 7 from 0? Well, it's 7. So it's positive. Now we can do it as an expression here. The absolute value of 4 minus the absolute value of negative 6. So what's the absolute value of 4? 4. What's the absolute value of negative 6? 6. And you subtract them. So when we talk about absolute value, you can end up with a negative answer based on the absolute value thing. So don't stress about that. Okay, but don't do additive inverse. Like don't do 4 plus positive 6. That doesn't work because that is the bad way of doing it. Okay, let's look at this one with distributive properties. So we have to deal with the absolute value first here in the middle. So 2 minus 7 is negative 5. So then we have 5 minus 3 times. And what's the absolute value of negative 5? Positive 5. Then we multiply these first. So then 5 minus 15, and then we end up with negative 10. And they just get more complex. Like this one here is a big absolute value. So no matter what happens, whatever our answer is, it's going to end up positive because the absolute value are on the outside. So you just do the work. 5 minus 7, negative 2, negative 2 squared. Yeah, that's positive 4. Negative 2 times positive 4, negative 8 plus 6, negative 2, and then the absolute value of negative 2 is positive 2. Okay, so flip to the second page, and we're going to talk about graphing. We're going to do two of them. We're going to do linear on the next page, and then we're going to do quadratics on the last page. So let's do linear. So linear, when you're talking about this, it's called a piecewise function because it's made up of two different pieces. So what you want to do is you got y equals x. In this case, we have y equals the absolute value of x. But let's graph y equals x first. If we graph y equals x, it's going to look like this, just like that all the way through. That's our normal y equals x. Well, the thing is we can't have negative y values because we're taking absolute value. So what happens is we end up, everything that was down in quadrant 3 flips up into quadrant 4. So it's composed of two pieces. So here's the original piece on the right, which is x is greater than or equal to 0. The original piece always includes that point. And then the new piece is x is less than 0. And all we do here is, you see, we just throw a negative in front of it. So any linear we can turn into a piecewise just by graphing the original and then flipping it. Okay, so let's take an example as the best way. So consider y equals the absolute value of 2x minus 3. Ignore the absolute value for now and just graph it like y equals 2x minus 3. So y equals 2x minus 3, you would start at negative 3, up 2 over 1, up 2 over 1, right? So here you can see this would be the original right here if it's graphed in. And then what happens is you see where the x-intercept is. All of that stuff that's below it gets flipped above it, okay? So we can do that. And if you're struggling with it, just do a table of values. That's an easy way to do it. So the x and y-intercept, if you want to do that, find the y-intercept, set x equal to 0. The y-intercept is positive 3. If you want to find the x-intercept, yeah, set y equal to 0, plug it in, you find out it's 3 over 2 or 1.5. So you can graph it. So there is the piecewise. Now, it's composed of two different pieces. This part here on the right is the original, and this part on the left is the flip, okay? So part on the right is the original, and part on the left is the flip. So let's look at what that looks like as a piecewise. We'll go down. We'll talk about the domain and range in a second. So there's the original, y equals 2x minus 3. That's it. Take out the absolute value and just write the original equation, 2x minus 3. If x is, remember, the original has to have the greater than or equal to or less than or equal to. It has to have the equals part of it. Greater than or equal to 3 over 2, right? Because that's where the x-intercept sits. So everything greater than 3 over 2, that's the original. Now the piecewise is the stuff on the left of it. And all we do is we put it in brackets and make it negative. You do this every time. Write out the original, put it in brackets, make it negative. That's how you break down the piecewise. And then in this case, if x is less than 3 over 2, it doesn't include it in this time, the equal sign, because we included it in the top one. So that would be everything over here on the left. Okay? And then domain, you could write it. Domain is negative infinity to positive infinity. Range is 0, including 0, and then everything up to positive infinity. And you can either write it as interval or set notation. It doesn't matter. So when you're dealing with a linear, graph the original. Everything that's below the x-axis then gets flipped into the y, into the positive. And then your piecewise, right? Look at the original, and then look at the second part, which is the flip, which just turned it into a negative. Okay, so go to quadratics. The next page is quadratics. So again, same concept. There's a quadratic, negative x squared plus 2x plus 8. Graph the original. So if we graph the original, right? There it is here, positive 8, and it's negative, it opens down. So you can see the red part of it here, the black, and then the red part. And what's going to happen is everything below it's going to get flipped up. So we get like a nice W shape, right? The red here is just to show what the original looked like. Well, there's lots of ways to graph quadratics. You know that. Let x equal to 0, solve for y. Let y equal 0, solve for x. That tells you the y-intercept. That tells you the x-intercepts. How do you find the vertex? Oh, you can complete the square if you remember how to complete the square, right? Push the 8 to the side. Take out the negative. So then we take negative 2 divided by 2, and we negative 2 divided by 2, and then we square it. So we end up with positive 1. And normally we'd out here, we would subtract 1, but it gets attacked by this negative here. It becomes positive 1. We can find the vertex. And there's multiple ways to find the vertex. You can use the formula x equals negative b over 2a. You could find your x-intercepts and take halfway between those 2 points. Either way. So the original was this piece here, right? The parabola going down. And what we did is we flipped it. So when we do the piecewise, we have to do the original and the piecewise piece. So the original is the stuff in the center. So you can see it goes from negative 2 to positive 4. Does it include those points? Well, yeah, let's look at the piecewise here. So here it is, negative x squared plus 2x plus 8 if negative 2 is less than or equal to x, less than or equal to 4. So it's everything between negative 2 and 4, including those points. Now, to do the second part of the piecewise, all we do is we put that in brackets and make it negative. You don't have to change it, just put it in brackets and make it negative. Then we look for our piecewise. It's everything less than negative 2 over here, but not including it, and everything greater than 4 over here, but not including it. So then we set it up as x is less than negative 2, or x is greater than 4. Okay, so again, graph the original, take everything down the bottom, flip it up the top, and then break down your piecewise.